In order to learn about the sampling distribution of the sample mean, I am a big believer in using an illustration to drive the process of learning about a concept. So, in line with that principle, I'm going to go back to page 3 of your notes. There was a story we developed there. So, here we are on page 3 of your notes, and we would like to revisit this scenario. What was the scenario about? Quickly. Well, we learned that we have an official who happens to be the director of tourism in a Caribbean country. And the goal of this Caribbean director of tourism is to estimate the average or the daily expenditure for adult visitors to this country. So what is unknown? It is how much on average an adult visitor to this country spends. As a statistician, if this director contracts me to help him or her find this unknown average, this is what I will do if I'm going to use the idea of sampling distributions. For example, I can decide to take a sample of 780 adult visitors who provide data on how much they spent on average when they visited our country. So let's say that after I collected data from the first sample of 780 visitors, I added up all what they spent on average and I divided by 780. What I will get is an X bar. Well, I'm going to put a 1 here, which means the first sample mean gotten from this 780 adult visitors. Let's say that it was $318.69. Well, I won't stop there because I know that if I push back all the names or all of these people that I have in this first sample back into the pool, and I randomly draw another 780 again, another 780 visitors. Now, these 780 visitors can have just about the same people or different people or a mix of those people. So I would combine or add up all of their averages for the day, and I will get another average for this 780 visitors. So let's say I get $360.05. I will repeat this process, let's say, m times. So that means I will have X bar the mth time. Let's say the last one was about 357 and 14 cents. Now, what I'm going to do is, with this repeated sampling process, I'm going to generate repeated possible averages. Then I might decide to construct a histogram of all of these possible values. That histogram will represent the sampling distribution of all the average daily expenditure of adult visitors to the country. This is what this topic is all about. So let's go back to our other page. Here we're back to page 8 of your notes. So when we learn about the sampling distribution of the sample mean, we will collect m samples, and each of them can have a size that you predetermine. In the illustration I've just given, our n was equal to 780. And if this sample size is large enough, we can compute each sample's what? Mean, and create a histogram of those means, and then the resulting distribution will usually tend to have an approximate normal or bell-shaped distribution. In other words, you can start out with a distribution that looks like this. As you increase the sample size, n equals 2, n equals 6 to n equals 30, as it nears 30, you observe that the shape of the distribution begins to approach the normal distribution that we learned earlier. So here is something to always note. You should remember that it does not matter the shape of the distribution you're starting with. what is most important, or the most important fact, is that as you randomly sample many samples from the population, the distribution of the sample means will eventually follow the normal distribution under certain conditions. What are those conditions? For one, you should note if the parent or original distribution is a normal distribution, then the size of the sample we draw from this population is not relevant. We will discuss more about that soon. Then, if the original or parent distribution is not a normal distribution, then the size of the sample we draw at each point from this population must be greater than 30, greater than or equal to 30, precisely, for the sampling distribution of the sample means to be approximately normally distributed. Please note that for the purpose of this course, the sample size of n equals 30 or more will be considered large enough. And every sampling process, that is, the process of choosing members who would be in the sample for which we'll compute a sample mean, is a process that involves sampling with replacement. Let's start getting into the theory of the workload here. Let's take case 1. In this scenario, we are looking at the sampling distribution of the sample mean when the population has a normal distribution. I like to call it the parent population has a normal distribution. In that case, the distribution of the values of the particular sample statistic for all possible samples of size n, and that would have the normal distribution. To illustrate, let's begin. In module or in earlier chapters, we learned about the normal distribution. Whenever we talk about the normal distribution, we talk about a random variable x that has the normal distribution, and it is defined by the mean, that is the middle value, and the standard deviation, which is that metric that measures how spread out all values are away from the typical mean or average value. These, for the purpose of this topic, we'll refer to as the parent or original normal distribution. If from this distribution we draw repeated samples, repeated m samples, each of size n, and we compute the sample mean. We compute the sample mean for each sample. It means the sample mean, which is x bar, will also have a normal distribution. In other words, this is the summary of what we're saying. If we start out with a normal distribution, the distribution of all the sample means will also have a normal distribution. Well, every normal distribution should have a mean and should have what? A standard error. So this would be the mean of all possible means, and this would be the standard error or standard deviation of all possible sample means. This mean is called the mean of the sampling distribution of x bar, and this quantity, the standard deviation of the sampling distribution of x bar, is called the sample error, or the sampling error rather. So how do we find them? The formula is the sampling error is the population standard deviation divided by the square root of n, whereas the mean of the sampling distribution is exactly equal to the population mean. What do we mean by this? Let's take an example. In this example, we are told that suppose that movie ticket prices in one area has a normal distribution with a mean of 8.32 and a standard deviation of 0.32. In other words, as far as we have just read, that is the highlighted part on the screen, Let me highlight that again. For the highlighted part on the screen, we're starting out with a distribution that is normally distributed. It has a mean of, let's draw this very well. It has a mean value of 8.32 and a standard deviation of 0.72 in the entire population. The requirement is that we should derive the sampling distribution of the sample means. Take note, in the parent distribution, our X here represents movie ticket prices, whereas for the sampling distribution of the sample means, since we're starting off with a normal distribution, we can only derive a normal distribution from a normal distribution. And this is the distribution of the sample means, which is X bar. And in the middle, you have the mean of all the X bars, which is equal to exactly the population mean. In other words, it is equal to 8.32. We're done. So, as far as this question is concerned, where we are told to find the mean of the resulting sampling distribution, that answer is provided as highlighted on your screen. The mean of the sampling distribution of the mean is exactly equal to the population mean from the normal distribution, which earlier was given as 8.32. Then we proceed in the same context of the problem. We suppose that the same movie ticket prices in one area has a normal distribution with a mean of 8.32 and a standard deviation of 0.72. So again, we start off with the parent distribution for movie ticket prices, that is represented by X as a placeholder, and it has a normal distribution where the mean is equal to 8.32 and the standard deviation for the population is 0.72 cents. Now, in this case, ticket prices are recorded for samples of n equals 52 theaters. We are to calculate the standard deviation or the standard error of the resulting sampling distribution of the sample means. So, for the sample means, X bar, what is the mean of all the sample means? As we said earlier, that is exactly equal to the population mean of 8.32. However, the standard error is given by the formula population standard deviation divided by the square root of the sample size. So, to find this standard error required in this question, standard error of the sampling distribution, that is denoted by sigma of subscript X bar, that is the population standard deviation divided by the square root of n. This will be equal to, what is the population standard deviation? 0.72, this was provided in the question, divided by the square root of n. N is our sample size, that is divided by the square root of 52. This is equal to 0.0998. This is the standard error of the sampling distribution of the sample means. So, take note of one point here, that even though we started out with a normal distribution, we always end up with the normal distribution for the sampling distribution of the sample means. As we progress, we will learn that regardless of the distribution of the parent distribution, the sampling distribution of the sample mean will have a mean equal to the mean of the population and its standard deviation, that is the standard error of the sampling distribution of the sample means, will be equal to the standard deviation of the population divided by the square root of the sample size. So, at this point, we're ready to take further examples on this. Hold your horses. You'll find out that it is not maybe as intense as it sounds. So, let's proceed. We proceed to the next page. On the next page, we're to complete parts A through D for the resulting or for the sampling distribution of the sample mean shown in the accompanying graph. So I can see that this population right here has a normal distribution. It has a normal distribution. So I'm going to let that be X. So my X here has the normal distribution with a mean of the center value, 500, and a standard deviation of, for the population standard deviation, you can see the markers here. These are the points of inflection. So the population standard deviation here is 530 minus the previous value here, 530 minus 500, that is equal to 30. So we have the mean of 500 and the standard deviation of the population to be equal to 30. Question A, what is the mean of the sampling distribution? Mean of X bar, according to the formula we had earlier, it is always exactly equal to the population mean. So adapting that formula, we have mu, and what do we have earlier? Our population mean was 500, that stays the same, and we're done. Question B, we have to find the sampling error of the sampling distribution of the sample mean. This is given by the formula we saw earlier, which is the population standard deviation divided by the square root of the sample size. So, using that formula, we have this divided by this. What is the population standard deviation? That was 30. So we have 30, we have 30 divided by the square root of n. Our n in this case will be taken from question C here. So, apologies there, that was supposed to be recorded here. So n equals 9, so we have 9 here. So that will be 30 divided by, what is the square root of 9? That is 3. 30 divided by 3 is 10. So, based on what we have here, we are told that if the sample size is n equals 9, what is likely true about the shape of the population? Well, since we're starting with a normal population, the truth is when n is equal to 9, the sampling distribution will also follow a normal distribution. So, to emphasize, since the original population is a normal population from which we can see here, it means that the resulting derived or sampling distribution of the sample mean will have exactly the same shape regardless of the value of your sample size. So even when n is 9, the shape of that population, of that sampling distribution, will also be the normal distribution. Then, question D. If the sample size is n equals 9, what is the standard deviation of the population from which the sample was drawn? We did this earlier. It is the standard deviation is sigma over the square root of n, that is 30 over the square root of n, which is 9, and we got 10 earlier. So this is very, very important. The summary of what we have done so far is this. We started out with a population that was normal, where you have a mean of 500 and a standard deviation of 30 for the values of x, and we want to derive the sampling distribution of x bar. They will share the mean of x bar would be still 500, the same mean, but they will have a different standard deviation or standard error in this case. And this derived one will be derived from the previous one by taking the previous standard deviation, which is 30, divided by the square root of n. So that will be 30 divided by the square root of 9, which we got to be 10. So, parent distribution, then the sampling or the derived sampling distribution. That is it. That is the gist of this page.